Okay, this is an example involving combinations. So here's the question. A committee of 3 people must be selected from a group consisting of 4 lawyers, 3 teachers, and 1 minister. So our first part to this question says, how many ways can this be done if there are no restrictions? So this is a combinations question. We're just making a group of 3. So it's a NCR, right? A combination. You just have to decide what is N and what is R. Well, N is the total number of people you have to select from. So in this case, N would be the 4 lawyers, the 3 teachers, and the 1 minister, which is 8. And R is how many you're selecting. In this case, R would be 3. So NCR would equal 8C3, which is equal to 56. So therefore, there are 56 possible committees. Okay, part B. How many ways can this be done if there must be exactly 1 lawyer? So of the 4 lawyers, or of the 3 people in the group, you have to have 1 lawyer and then kind of 2 others. So what we can do in this question is think of it in 2 parts. Think of it as action 1 and action 2. This would be like fundamental counting principle. So action 1, you must select a lawyer. And then action 2, you must select the 2 other people. I'll say 2 others. Right? So these are the 2 others. This is the lawyer. So how many ways can you select a lawyer? Well, how many people are there to choose from? There's 4 lawyers to choose from. And how many do we need to select? 1. So it's 4C1, which is just 4. And then you must select the 2 others. So how many others are there to choose from? Well, there's 3 teachers and 1 minister. So again, there's 4 others to choose from. And you're choosing this time 2. And 4C, which is 6. So the total would be action 1 times action 2. Right? So 4C1 times 4C2, which is 4 times 6, which is 24. So therefore, there are 24 possible committees. Okay, so that's how you do this one, where we throw in a restriction of exactly 1. How many ways can this be done if there must be at least 1 teacher? Okay, so the sort of key words here is at least 1. So when you think of at least 1, what does that mean? That means 1, 2, or 3. So you must have at least 1 teacher, meaning you must have 1, 2, or 3 teachers. So you can do that in cases. Case 1 would be 1 teacher. Case 1. Case 2 would be 2 teachers. Case 3 would be 3 teachers. So how many ways can we do all these things? Well, again, you're going to have to think about this in parts. So I won't write down as much as I did in last cases, but just to remind ourselves, we must select 1 teacher. So that's going to be my first action, selecting the teacher. Remember, there are 3 teachers to choose from. So if we want to select one of those 3, that would be 3, choose 1. But remember, we must fill up the other 2 spots in the committee. So you're going to multiply this by those other 2 people. So how many other people do you have to choose from? Well, there's 4 lawyers and 1 minister, which must fill up those final 2 spots. So since there was 4 and 1, that'd be 5, and we're choosing 2 of them. Okay, so that would be 3 times 10, which would be 30. Okay, and then same thing. So now your first action, you have to select 2 teachers. So instead of selecting the 1 teacher, you have 3 teachers to choose from, and you're going to choose 2 teachers times. Now, similar here, you still have 5 people to choose from, but we're choosing just the 1 of them. So we're going to have 3 choose 2, which is again 3 times 5 choose 1, which is 5. So we've got 15 ways. And then the third one, you're going to select 3 teachers this time. So 3 teachers, and we're choosing all 3 of them, times, and now you don't really need this part because you have 5 other people to choose from, but you're not choosing any of them, right? You're choosing all teachers and 0 others. So this is really just equal to 1 times 1. So this one's equal to 1. So if you didn't even want to write this, you don't need it, and a lot of people won't. So that's just one way. So there's one way to select a committee of all teachers, which should make sense. And now these are cases. They're all distinct cases, right? They can't happen at the same time. It's this case, or this case, or this case. So that would tell you it's the rule of sum. So we're just going to add these numbers together. So by rule of sum, there are, so 30 plus 15 plus 1 equals 46 possible groups. Okay, so this was just one way to do this question. I'm going to show you the other method, which would be what we call the indirect method. And you can see for this question, the indirect method would actually be a little bit quicker. So remember, in this original question, it says how many ways can you form the group if you have to have at least 1 teacher, and we said at least 1 meant 1, 2, or 3. Well, what's the cases that aren't included? So sort of sometimes we'll say the opposite, and that would be selecting 0 teachers. So the indirect method, we're just going to look at sort of the other case, the case that didn't fit into what we wanted, 1, 2, or 3. So if you want 0 teachers, well, it's going to be very similar to right here. So you have 3 teachers to choose from, and we're going to select none of them, times 5 others to choose from, and we're going to select all 3 others, and that's equal to 30. Okay, so this is how many ways we can select the group that don't meet this condition. But remember, up in part A, we figured out, oops, sorry, I made a mistake. This right here, it's not 30. 5 choose 3. Let me just redo, let me erase this. Oh, let me get a better eraser. Okay, there we go. 3 choose 0 is 1 times 5 choose 3, which is 10. So this is equal to 10. So there's 10 committees which do not meet the condition of having at least 1 teacher. So it means there's 10 committees without a teacher on it. But remember, back to the original part, there was 56 possible committees. Well, if there's 56 possible committees, so this is all committees. and then you subtract the 10 that don't have a teacher, so no teacher. Then you're going to be left with all the ones that do have teachers, which is 46, which is the same as the answer we had over here. So that's good. And you can see this one's a little bit quicker because you only had to really consider that one case of no teachers, which is a lot easier than considering the 3 cases of 1, 2, and 3 teachers. And the final example, how many ways can this be done if you must have at most 2 lawyers? So again, what does at most 2 mean? At most 2 means, it means 0, 1, or 2. So that's at most 2. But notice, so we could do cases for 0 lawyers, 1 lawyer, and 2 lawyers, but it's probably going to be easier to, again, do the indirect method. So I'm just going to do this one way. So why is it easier to do the indirect method? Because sort of the opposite to these 3 would be selecting all 3 lawyers. Okay, so if this is the cases that satisfy, just look at the other case, or cases. Sometimes it will be more than one case. So indirect method, consider all 3 lawyers. So if you're going to select all 3 lawyers, how many lawyers do you have to choose from? Well, if you remember, you had 4 lawyers to choose from, and you're going to choose all lawyers. And really that's all you need, but if you want to look at the others, there were 4 others to choose from, but we're not going to select any of them. So that would just be equal to 4 times 1. So this thing right here is 1, so you don't really need it, which is equal to 4. And then you're going to subtract this answer from that total. Remember the 56. So 56 minus 4 equals 52. So therefore, maybe I'll just write why that we did that. So total cases, total groups minus all lawyers. So therefore, there are 52 possible groups.